assignment 6, question 2, which is using the multiplication and addition principles. So the question is asking how many positive integers with distinct, which means different digits, can we make, or are there? So I just want to remind everybody what the addition principle is. I just have a quick definition here. And let's just remember that E stands for event and N stands for the number of ways that the event can be represented. Likewise, the multiplication principle basically stands for the same thing. We are just making sure that in the end we are multiplying. Okay, after that quick little description, let's just jump right into it. So as a quick review, the biggest number that we can have with different distinct digits is going to be a 10-digit number. So that's what we're going to be looking for. This is because we can have numbers from 0 ranging to 9. That's 10 numbers. Remember that 0 cannot go in the first place value for the number. So remember that single digits cannot be bigger than 9 because it would break the rule of it being a single digit. A 1-digit number has 9 options in this case. So we're looking for a 10-digit number. So the 1 digit, the ones place value has 9 options. 0 cannot be one of them. Now, why can't 0 be one of them? Well, this is because 0 is a placeholder. It has no value if it's at the beginning of a number or is the single digit. So a 2-digit number is a little bit different. It does still have 9 options for the 1 place value, and it also has 9 options for the 10th place value. This is because the 10 place value, pardon me, this is because the 10th place value cannot be 0, so cannot be 0, and the 1's place value cannot repeat the number in the 10th place. So moving on, by using the multiplication principle, we know that we have 9 options for the 10th place and we have 9 options for the 1's place. So we can multiply both those 9's together to see how many options we have for positive 2-digit distinct digits. So we know 9 by 9 is 18. Therefore, there are 81 options. So we're going to move on to 3-digit numbers here. So we know that there are 81 2-digit numbers with distinct digits. We used 2 options already, meaning we only have 8 options left when we're looking for 3-digit numbers with distinct digits. So what I mean by this is to get our 2-digit numbers, we used our 9 options. We used our 9 options because we can't repeat numbers, but we can use 0 in this one, and we can't repeat numbers, and we can't use a 0 in this one, so that gives us 9 and 9. Well, this option, for the ones now in a 100 number, we only have 8 options left because you can't repeat numbers. So by cross multiplication, I would like everybody also to do this. So we can go 9 by 9 we know is 81. So 9 by 9 is 81. And by cross multiplication, we can do 81 times 8. Sorry, it's going to kind of go into that. 8 by 1, is 8. And 8 by 8 is 64. Therefore, by cross multiplication, we know that 9 times 9 times 8 is 648. So I'm going to challenge everybody now to pause the video and continue the pattern. We're going to start next with 4-digit numbers. I challenge you to do it as far as you can without a calculator. Now I'm going to scroll down to the answers here that I have written out. So by the addition principle, now that we have all of our numbers, so this is the, oops, we're still on drawing mode, sorry. Just going to go back here, sorry guys. There we go. So our 4-digit numbers, we have 4,536 options. 5-digit numbers, we have 27,216 options. 6, 7, 8, 9, so on, all the way up to our 10's digit number, which is the last one we're looking for. 11 digits automatically repeats the number, so that 10 is where we stop. So by the addition principle, we can now add, I'll write that in. We can now add all the numbers together. We no longer have to multiply since we have multiplied all the events together for each number with a different amount of digits. So now the final step is to add all the events together to get the number of ways it can occur. So that means we're adding the number of ways the positive integers can occur with distinct digits because we already found what each significant number means and how many different ways you can have that. So big numbers, guys, you can use a calculator, see how far you can get to without using a calculator. I did end up with a large number. It's 8,877,690 positive integers with distinct digits. All right, awesome job, guys. That is it. That is our answer. If anybody has any questions, feel free to email me.